Hi, Miss Curdy here. Today we are going to be starting topic 2 and topic 3. For this topic, you're going to need 2 note sheets for the first lesson. The first one is a topic 1 review, and the other one is for topic 2-3. You're going to notice that for topic 2 and topic 3, we're going to be jumping around a lot. We are not going to go in order for starting at 2-1 and 2-2. And so on and so forth. We're going to be in 2-2, and then we'll be in topic 2, and then we'll be in topic 3 a little bit. So just make sure that you're following along and using your packet to make sure that you are working on the right lesson in the right order. All right, so let's take a moment and we'll get those 2 sheets, and then we will start. Here is our topic 1 review. So in topic 1, we really focus on the meaning of multiplication and making sure that when we are showing our repeated addition, our pictures, and our arrays, as well as our jumps on a number line, we are keeping the meaning in mind. Topic 2 and 3 are going to be a little bit different because now that we know what the meaning is, we can use that to our advantage and also the commutative property to make sure that we're multiplying more efficiently. So let's just review the different ways to represent multiplication. So for example, there's repeated addition. In this case, we'd have 3 groups of 4. So we'd have our 3 lines, and we would add 4 multiple times. If we were drawing a picture, we could draw 3 circles, and we would put 4 in each. And if we were making an array, it would mean 3 rows of 4. So we can show it this way, making sure the meaning is correct. When we're looking at jumps on a number line, we would have 3 jumps of 4. There's Carl walking through. So let's do our 3 jumps of 4, 8, and then 12. Okay, buddy. 3 jumps of 12, and in each case, our answer would be 12. Sorry, 3 jumps of 4, and our answer is 12. We talked about the commutative property, which means we can switch the factors around and get the same product. It would have the same product, but a different meaning, and that's really useful depending on our equation that we can focus on one number or the other. And in class, we talked about how showing these problems are very different. The meaning of them is very different. In this case, we have 90 groups of 3. Here we have 3 groups of 90. So if you had to show that as repeated addition, this one would be definitely a lot easier to show than 90 groups of 3. Throughout this unit, we're going to be looking at both factors and deciding which way our equation will be more efficient, and we'll be able to switch our factors around throughout the next 2 units. All right, so our first unit that we're going to be talking about is topic 2-3, and it is our factors 0 and 1. These are probably the 2 easiest factors. Let's just pause a second to look at our producer over here, Carl. Psst, how's it going, buddy? He's laying here watching. Let's take a look. We have 0 and 1 as factors. So in this case, 0 as a factor is really simple because when we're looking at 0 as a factor, what it means is that we have 0 groups or empty groups, and the answer is always going to be 0. And you can think about it 2 ways. For example, it could be 0 groups, or you could have empty groups where there's nothing in each group. So we actually have a property called the 0 property, and it says that any factor times 0 is 0. And let's take a look at a couple of examples. Down here we have 0 times 7, which means 0 groups of 7. So although there are 7 in each group, there are no groups, which means we have nothing. Over here, the meaning's slightly different. Here we have 6 groups, but there's nothing in any of those groups. So again, we still have nothing. So anything times 0 is 0. Take a look at this problem down here. 0 groups with 700 in each group would still leave us with nothing. 0 groups of 89 would still leave us with nothing. And you can even switch these factors around. 89 groups, but there's nothing in them, would still equal 0. 700 groups with nothing in them would also equal 0. So anything times 0 is going to give us 0. Down here, we have 1 as a factor. You can either think of it as one group, or that there are several groups and there's just 1 in each group. When we look at the identity property, which is what we call the the property when we're multiplying by 1, says that any factor times 1 is the other factory. And I like to think of it as that the other factory gets to keep its identity. It doesn't change. It gets to stay who it is. So down here, 1 times 7, we would have the meaning one group of 7. And if there's one group and there's 7 in each, our answer would be 7. Here we have 6 groups with 1 in each, and that would come out to 6. So 6 groups, 1, 2, 3, 4, 5, 6, with 1 in each would give us 6. These multiplication equations are also really easy, just like when we have the 0 property. Anything times 1 is that other number. So 1 times 700 would just be 700, and 1 times 89 would just give us 89. So that concludes this lesson as 0 and 1 as factors. Remember, the 0 property says anything times 0 is going to be 0. And then we have the identity property, which states that anything times 1 is just that other factor. Go ahead and start working with these in your workbook or on the computer, and have a great day. And I'll see you back here for the next video. Bye.